Alright, here we are in Chapter 4, Section 4.1. We're going to be looking at graphs of sine and cosine functions. And it'll continue on in 4.2, looking at sine and cosine and looking at shifting them left and right. And then we'll move into tangent and cotangent, and that will wrap up our week. And then we'll look at some more graphs next week. So as we look at the sine, we have this chart over here that matches up what we know the sine of 0 is and pi over 6. And so we want to get just a quick sketch of what's going on. And so we know that sine of 0 is 0, and these all represent angles right here. And then we go up to a height of 1, and we fall back down. Now we go up to a height of 1 at pi over 2, and at pi we're back down to 0. Then we go down to a height of negative 1 at 3 pi over 2. Then we go up through 0 at 2 pi. And notice that's one full period of sine. We've ranged all of its we've ranged through all of its range values. And then we go up like this, right? And where is that? Well, 2 pi plus pi over 2. So that's going to be 5 pi over 2, and so forth and so on. And so we get all of that going on here. It does exist over here. This is negative pi over 2 and negative pi, and back up at 1 at negative 3 pi over 2. Right? And so it makes sense how it's going. It makes sense that take a look at something really quick. Remember, these are all, I'll put them on right here. These angles right here between 0 and pi over 2 are all quadrant 1. Of course we're positive. Then if I make it blue and we come in here, quadrant 2 is right here. This is quadrant 4 back here. And so is this. Right? These are quadrant 4 angles right here. Remember, it's a circular function, but they're laid out on this nice linear graph. And so we can look at this and realize, oh, the domain is really all reals, anything that you can think of. But it's agreeing with what we know should come out of this. So let me go back in here, get rid of that yellow mark there too, and go ahead and put back in our axis right in the middle there. So we're not looking for perfection, just some patterns. And so we know from our work at the beginning of the chapter what a number out in front did. And I apologize, I shouldn't have said beginning of the chapter, beginning of our course. In those initial pages in this worksheet, we had you look at some functions that were kind of standard functions, and go ahead and see what happened if you put a number out in front, if you added a number after the fact. So we know what's going to happen for y equals sine of 3x. I'm sorry, y equals 3 sine x. I said that wrong. That is going to, let me just write that right here, 3 sine x. And y equals 3 sine x plus 1, and y equals sine 2x. So I want to be your friend in here and try to help you out as much as possible. My suggestion always is to do your work in pencil and then adjust as needed. So 3 sine x. So what's going to happen? We're still going to start at 0, 0. But instead of going through 1 at pi over 2, we're going to be way up here at 3. So we're going to come way up here at 3, fall back down to 0. Right? This is the pi over 2 still. This is pi. Going to fall down to negative 3, right? So this is 3, this is negative 3, and what we get is a change in what we call amplitude. Okay, there's a, well, we've already done more than a full period, coming back down, and then going down to negative 3, and that just keeps going on both sides, right? And so, I apologize, I need to get way down here to negative 3. In that swoop, and then come back up here to 0, and then way up here to negative 3. Okay, so that's what sine 3x looks like. There's no side adjustments or anything. So what happens when I have sine of 3x plus 1, or apologize, I said that, 3 sine x plus 1, I would still do the same thing. I would draw this exact same graph going up, 2, 3, coming back down, going down 1, 2, 3, turning around and coming back up in that little interval, coming up to 3, coming back down to 0, going down to -3, and keep going. I don't know how much you want to show, but we'll just fill that all in, and then it definitely continues down here as well and over there. Now notice that's not perfect, but this is still pi over 2, this is still pi, this is still 3 pi over 2, right? I apologize, 3 pi over 2 is right here. Pi is this guy right here, and this is 2 pi again, where it does its complete rotation through there. Sorry, I have it all condensed in there. Now remember, we have this plus 1, so what do you remember about plus 1? Plus 1 added after the fact, like we did on those initial pages, moves the graph up 1 unit, which means I'm going to keep everything the same. And remember, I said do it in pencil. Erase that original x-axis and move it 1 unit lower. Okay, it was going right there. Now it's 1 unit lower. But this is still pi over 2 at that first line. Pi right here where it's crossing 0. That's all still, I'm sorry, pi right here where it's crossing 0, right? Because these are axis lines. Okay. Let me get that line back in here, but we draw it 1 lower. So I'm claiming that at pi over 2, we're way up at 1, 2, 3, 4 now. And that's true. Sine of pi over 2 is 1 times 3 is 3 plus 1 is 4. Excellent. And so it's all going to work out. This 2 right here is a period adjustment. And so it seems a little bit premature to have you drawing these things. But let's take a look at what's going to happen there. If you look at the original sine function, it repeats itself. Let me go through with the highlighter. It repeats itself after 2 pi. We'll get that exact same yellow curve to the right and to the left. And so sine has a period of 2 pi. Now, if you have a number on the inside, it adjusts that period. And we get a new period by taking the original period and dividing it by the number that's there. So now everything's in a pi. So what would I do? I would do the exact same thing that I've been doing. Start at 0, 0, go up to 1, right? Down to 0, down to -1, up to 0, up to +1, down to 0, down to -1. It gets very repetitive, right? You get that type of streak. Now, the change is it's going to do a full rotation in just pi now. So this is pi, and you just change the labeling. This is pi over 2. This height right here is pi over 4, and this is 3 pi over 4, where we're getting down low. And so this is negative pi over 4. And right here is negative pi over 2. And we get that nice graph going on there. Sorry for the hesitation. I thought I heard something. So, what's the domain of sine? Easy. You can plug any angle you want into sine. The range of sine, though, is just from -1 to 1. It can't get any bigger than that. That's what we were taking advantage of when we were in Chapter 7, is that when we had that ambiguous case and there were no solutions, it's because the sine value was falling outside of that range. Sine is what they call an odd function. An odd function is symmetric about the origin. And so if you look at this, guys, it's definitely not symmetric about the y-axis, but it is symmetric about the origin. And what's unique about an odd function is sine of negative x is negative sine x. You might have dealt with odd functions in your Math 120 class, your intermediate algebra class. The sine function is periodic with period 2 pi, like we identified. It has intercepts on all the multiples of pi. Its y-intercept is 0, 0. The maximum value occurs at 1, occurs at all the odd multiples of pi over 2. And minimum value also occurs at these odd values of pi over 2, right, the alternating ones. And so just some observations. Now when we go to cosine, what do you know about cosine? You know the cosine of 0. What's the cosine of 0? The cosine of 0 is 1. So it's going to start high and fall, right? Can't get any higher than that. Come down here, come up to there, fall back down through 0, and then very just methodical going through. So this is at 0. It's reaching its peak at 0. It's getting all of its zeros at these odd multiples of pi over 2. This is pi in the middle where it falls. This is 2 pi up there. And you can see that it has a period of 2 pi again. This is negative pi over 2. Down to 0 at negative, or negative 1 at negative pi. Back up to 0 at negative 3 pi over 2. Right? And so forth and so on. Just get some labeling out there so we can see what's going on. So a negative, you know what the negative is going to do? The negative is going to flip us upside down. So what would I do? I take my regular cosine graph, and instead of starting at 1, I'm going to start at negative 1. So obviously we're going up, and then through here, down here, and then we just go. Now, you might be panicked because I haven't taken account the 1. I'm very methodical in what I do, not wanting to confuse myself, right? And so because of that, I get everything drawn in there. Let's remember what these are. These are all pi over 2's. This is pi. This is 3 pi over 2. This is 2 pi right in here. And so at all these multiples of pi, we are at these extreme points, right, with 0 being right there. Now, we know what's happening. We're taking this graph and moving it up 1, which means I'm going to come in here and erase my x-axis. It means I get a new x-axis 1 lower. So it's coming right through here. And then, so that's what I do. I just change what's there. I change where my 0, 0 is. Now, this is 0, 0 now. So my 0 did change. Get rid of that. Oops, get rid of that 0, but I will come back and put that y-axis there. Apologize. I thought I was off that line. So let me draw that in there. So what am I claiming? I'm claiming that at 0, I'm down at 0. Well, let's check that out. Negative cosine of 0 plus 1. Cosine of 0 is 1. Negative 1 plus 1 is 0. Pi over 2. Cosine of pi over 2 is 0. Times negative is 0 plus 1. And I'm up at 1, which is exactly where I'm at. At pi, I would be at negative 1. And so negative cosine of pi plus 1. Cosine of pi is negative 1. Negative 1 is 1 plus 1 is 2. So everything's working out exactly the way that it should. So that's my big recommendation. Do your work in pencil and erase what's there. Maybe even put in just a dotted line for reference. I don't know. So we know what this 2 on the outside is going to do from our experience in algebra. It's going to do the same thing with this trigonometric function. It's going to, instead of going up to 1, we're going to go up to 2. And the 4x is going to or the 4 in there with the x is going to adjust our period. So apologize, I was drawing sine. Forgot we were dealing with cosine. Cosine at 0 is 1, but now it's up at a height of 2. And we're going to fall and fall. And I'll just keep going on this side because I'm here. And then just fall and come back up and come up to 2. So now we get this amplitude of 2 and we're doing great. Coming right up through here. And I'm doing this live for you just so we can pace through it and talk together. Hopefully it's not driving you nuts. The period of cosine, like we saw from the original graph that's right here, is 2 pi. And so the period of this new function is going to be 2 pi divided by the number that's with the x, or pi over 2. That means it completes a full cycle in pi over 2. That means this point right here, right in the middle, is pi over 4. And in between those are pi over 8s, right? And we can get them in there. Pi over 4 plus pi over 8 is 3 pi over 8. And you can just get those in there. Just get some in there so I know that you know your reference points that are coming through. But how did I know that it was pi over 2? Because I knew the period was pi over 2. Half of pi over 2 is pi over 4, right in the middle. So down there, you want to check yourself? Let's do it. If we go check ourselves, let's check the pi over 4. I'm claiming that at pi over 4 will be negative 2. So y equals 2 cosine of 4, and I'm going to plug in pi over 4. Well, the 4's are going to cancel. This is 2 cosine of pi. What's cosine of pi? Well, that's negative 1. What's 2 times negative 1? Negative 2. And it looks like I'm perfect, right? You can check other points along the way, but it's great. The domain of cosine is from negative infinity to infinity. The range of cosine is the same, negative 1 to 1 included. Cosine is what we call an even function. Even functions are symmetric with respect to the y-axis. So let's go back up, and look at this cosine function that's here. And you can see that if we were to flip things over this y-axis, it would look exactly the same. It would fold over on itself. It's totally symmetric with respect to the y-axis. That's the characteristic of an even function. And so cosine of negative x is just cosine x. Cosine has a period of 2 pi, has its intercepts at all the odd multiples of pi over 2, and a maximum value occurs at the even multiples of pi, and minimum values occur at the odd multiples of pi. And then it talks about amplitude. Okay, amplitude is whatever that number is out there. So calculating the amplitude of 3 sine x, this guy has an amplitude of 3. And this one has an amplitude of 2, meaning off of that center line, we go up and down that amount, right? And so they want you to look at sine and cosine together, and they want you to make a conjecture about it. Here's what you should observe. You should observe that if you take the cosine graph, so let me highlight the cosine graph. So this is the cosine graph, right? No, it's not. This is the sine graph. So I'll just go ahead and highlight the sine graph since I made a mistake and grabbed that one. Sorry, those lines blurred together. That's definitely the sine because it goes through 0, 0. It's good that I did that mistake because sine's the one's there. They want us to make a connection between the two. Notice if I took this cosine graph that's unshaded and moved it to the right by pi over 2, I would have the exact same graph. Well, how do you move a cosine graph pi over 2 to the right? You subtract pi over 2, just like you know from your algebra days, right? Where is y is equal to x minus 2 squared? It's shifted 2 units to the right, right? It's a parabola shifted 2 units to the right. No difference between that initial work, which was a repetitive thing from your intermediate algebra days. They assume you know so much now. So, find the period of sine of x. No problem. The period of sine x we know is 2 pi. What's the period of sine 2x? It's the original period 2 pi divided by the number that's with the x, so it's pi. And let me just put p for period is equal to that. P for period is equal to that. So what would this be? This would be the original 2 pi divided by b. That's what the what do you call it? The period's going to be for that one. Okay. So let's take a look at graphing these guys. Give the period and the amplitude. So what we want to see is we know this guy right here is going to be the amplitude. Now the amplitude is 2, not negative 2. This guy is going to adjust the period. So we have an amplitude equal to 2. This negative tells us that the graph is flipped over the x-axis, just like in all your algebra stuff. There's no difference there. And our new period is 2 pi divided by pi, or plain old 2. So we'll take that to our advantage. So we're going to have to turn over our regular sine graph. So let's talk about sine. Sine started at 0, and we'd go up, except now it's going to fall down to 2, and then come up. And it's going down only because of that negative sign. And then we go up to 2, down, down to negative 2, up, up to 2 and down. And they don't have to be perfect coming through there. And then up to 2 and down to -2, right? It would just keep going like that. So what have we taken into account of? Let's put in green check marks. We did the amplitude of 2. You can't see that very well. Let me not do green. I'll do blue. We did the amplitude of 2. Why is that so light? Oh, because I'm gotten the highlighter pen. Amplitude of 2. Negative sign taken care of. All that's taken care of. Now I got to take care of the period. Well, that's easy to take care of. Let's just note what the period is. The period's 2. So let's have sine start here at 0. If we go out a full thing, we'd end up there. That's the number 2. So this is the number 1. This is the number 1/2. This is the number 3/2. This is the number 5/2. This is the number 3. 7/2. 4. Right, coming through there. So we would totally be able to label all of that. And so we don't do anything fancy. We just draw what's in there and go. So what about this guy right here? Okay, draw that regular one in there. We got an amplitude adjustment of 2, but it's the regular cosine. Cosine starts high and falls. And so we're going to start high and fall and go down to -2, come back up, go up to 2, come back down, go down to -2, come down, come down to 0, -2, back up to 0, and then we'll just keep this one going because we can. And they go on forever. I'm not one that will freak out if you don't have an arrow at the end, but some will. So we've taken care of the amplitude. We definitely have the cosine function. What's our new period? It's the old period 2 pi divided by 1/2. What's 2 pi divided by 1/2? It's not pi. 2 pi divided by 2 is 1/2. 2 pi divided by 1/2 is 4 pi. So now let's just trace out a period. I'll highlight it in case that's hard for you to see. I'm going to start always at 0. And I'm going to utilize that period. So once I get to the same ending point, that little V shape gets repeated over and over. That's a period. That means that this is 0. We already knew that. And where it ends is 4 pi. That means in the middle it's 2 pi. And right in between here it's pi. And right in between here it's 3 pi. And we got all those things labeled out. You could say, well, let me check it, Jensen. Sure. Let's try this pi one. 1/2 of pi, or cosine 1/2 pi, cosine pi over 2 is 0 times 2 is 0. We're good, right? And we can just continue to check those and find out that we're great. So now we get to write the function. And so here we are. We have our a graph that's here. So we have to determine whether this is sine and cosine. So I think step number 1 is to determine whether it's sine or cosine. And we tell that by what's happening at 0. So because we're up at a height at 0, this is going to be a cosine function. Okay, now they did say write the function. I guess I can do y equals. I was going to switch that out, and maybe I will, to f of x, just to stress that it's a function. Now, cosine, it does not look like there's a period adjustment. It looks like the period is 2 pi, so this is just x, but it does look like there's an amplitude adjustment of 1/2. And so we get a 1/2 cosine x. This one is also a cosine. How do I know it's a cosine? Because it is not going through 0, 0. So that's what they mean by assume no phase shift. They haven't talked about that. It's a horizontal shift. It's in the next section. So they're saying that because it'd be very hard to tell whether it's sine or cosine. In fact, you can make an argument that it's each based upon what we said earlier. But this is just a cosine graph because it's not going through 0, 0. Amplitude still 1, so there's no amplitude adjustment. But take a look at the period. One full period shown right here from dot to dot, because we start and get right back to that same point. Well, that's 4 pi. So this is 1/2 x on the inside. That's the only way I'm going to get a 4 pi period. Remember, it was 2 pi divided by that number that was there is equal to 4 pi. If you want to solve for b, well, you can do that algebraically. So algebra is there as always if you need it. You can think I'm skipping steps at times, but sometimes you don't need that algebra. You just know it's 1/2 based upon experience. Now this one's going through 0, 0, so this is a sine function. It's not going to 1, but it's going to 1/2, so there's been an amplitude adjustment. And the period does look like it's still 2 pi. If we go to D, that's a sine graph because it's going through 0, 0. Its amplitude is 3. And what's its period like? Its period's still 2 pi. And so we're done there. Now this has to be a cosine because, and its amplitude is 3. Is its period still 2 pi? Yep, it does look like its period's still 2 pi. And so it's just a nice x in there. Now, what is this one? It's absolutely a cosine function. There's no amplitude adjustment, but there is a period adjustment that's sometimes hard to see. So I'll tell you a trick. Count the number of times we get back to this point as we move to 2 pi. 1, 2, 3. So because of that, I now know that this is a 3x in here. Because it was 2 pi, but now I'm getting a third of that. And so 2 pi over 3 is the new period. It's hard to see that this ends right here at 2 pi over 3. So we just count the number of times. So we don't count the first one. This is 1 full period, 2 full periods, 3 full periods. That's your number underneath. Okay. And then, so if we use that same technique here, this is definitely a sine function with no amplitude adjustment. There is 1, 2, 3. So this is sine 3x in there. And then this one is also a sine function. No amplitude adjustment, so I don't have to put a number out in front. But if I look at the period's 4 pi. Well, we know where that came from. 1/2 x. That's what we'd love, is for you to just be able to say it came from 1/2 x. And so that's our examples for 4.1. You'll see other examples as you step into 4.2.